So today I'm going to be talking about Boyle's and Charles' gas law. So I'm going to start with Boyle's law, and Boyle's law is as the volume increases, the pressure decreases, and as the volume decreases, the pressure increases. They're inversely proportional. So if we take a look at the picture I have over here, you can see on the left-hand side that we don't have a lot of pressure going on, and there's a lot of volume. These particles are moving around freely. So as we start to increase the amount of pressure, we are decreasing the volume, and the particles are going to start colliding with each other. So if we go to the far right now, you can see that we have significantly increased the amount of pressure. So we have also significantly decreased the amount of volume, and these particles are colliding frequently. Boyle's law states that the volume of a fixed mass of gas varies inversely with pressure at a constant temperature. So the equation is P1 times V1 equals P2 times V2, P equaling the pressure of the gas and V equaling the volume of the gas. The temperature must be constant. So now for an example of Boyle's law. The pressure of air inside a balloon is 650 millimeters of mercury. The balloon has a volume of 24.5 milliliters. What will be the pressure of air inside the balloon if it is compressed to a volume of 8.2 milliliters, assuming that the temperature remains constant? So the first thing I like to do is plug in my values. So P1 is going to equal 650 millimeters of mercury. V1 is going to equal 24.5 milliliters. P2, I put a question mark because that's what we're going to be solving for. And V2 equals 8.2 milliliters. So the equation we have is P1 times V1 equals P2 times V2. So P2 equals P1 times V1 divided by V2. Now all you do is plug in your values. So P2 is going to equal 650 millimeters of mercury times 24.5 milliliters divided by 8.2 milliliters. So milliliters will cancel out, and your answer is going to be 1.94 times 10 to the third millimeters of mercury. And you want to make sure that you express your answer in scientific notation. So now on to Charles' law. And Charles' law is, as the temperature increases, volume increases at constant pressure, or as the temperature decreases, the volume decreases at constant pressure. So if we look at the picture, you can see that the temperature has decreased and the volume has decreased because you can see that these particles are pretty close together. If we move to the right, you can see we've increased the temperature and that has increased the volume. So now these particles have more room to move around. Another part of Charles' law is that the temperature must be in Kelvin since volume cannot be negative. So if you were to use Celsius in your equation, you would have a negative volume, and you don't want to do that. So to convert Celsius to Kelvin, here's the equation. You just take your degrees in Celsius and you add 273. So Charles' law states that the volume of a fixed mass of gas at constant pressure varies directly with Kelvin temperature. So V1 divided by T1 equals V2 divided by T2. So now for an example of Charles' law. 12.5 liters of gas at 30 degrees Celsius is heated to 110 degrees Celsius at constant pressure. What is the volume of the gas at 110 degrees Celsius? So the first thing I like to do, just like with Boyle's law, is plug in my values. So V1 equals 12.5 liters. T1 equals 30 degrees Celsius, T2 equals 110 degrees Celsius, and V2, I'm going to put a question mark because that's what we want to solve for. So the first thing that you want to do is convert your Celsius to Kelvin. So all I did here was take my degrees in Celsius and add 273 to each. So now T1 is going to equal 303 degrees Kelvin, and T2 is going to equal 383 degrees Kelvin. So the equation is V1 divided by T1 equals V2 divided by T2. So V2 equals V1 times T2 divided by T1. And then all you do here is plug in your values. So V2 equals 12.5 liters times 383 degrees Kelvin divided by 303 degrees Kelvin. So the kelvins cancel out, and the answer is 1.58 times 10 to the first liters. And you want to make sure that you also express this answer in scientific notation. So that's it. I hope that I explained Charles and Boyle's law so that you now understand it and you can go and teach your family and friends.